Time crystals have a unique advantage over many existing quantum systems: longevity. In quantum computing, one of the biggest challenges is maintaining coherence, keeping quantum states stable long enough to perform meaningful calculations or store information. Most systems lose coherence quickly, collapsing under the influence of their environment. But time crystals persist. Their oscillations endure far longer, making them natural candidates for something that quantum computing desperately needs: reliable memory. Imagine a quantum computer where information is not stored in fragile, fleeting states, but in robust, self-sustaining rhythms, where the passage of time itself becomes the storage mechanism. This is not guaranteed. It is not even immediate, but it is now conceivable in a way it wasn't before. Beyond computing, there are other implications. Time crystals could function as frequency combs, tools that provide extremely precise reference signals. These are already used in cutting-edge measurement devices, from atomic clocks to spectroscopy systems capable of detecting minute changes in matter. If time crystals can be engineered and stabilized further, they could push the sensitivity of these instruments even closer to the fundamental limits imposed by quantum mechanics. And that phrase, the quantum limit, is where the deeper significance lies. Because what this research ultimately represents is not just a new kind of material or a clever experiment, but a step toward controlling systems at the boundary where classical intuition breaks down completely. A place where motion doesn't require energy in the way we expect, where time itself can host structure, where the distinction between dynamics and stability begins to blur. We started with a simple idea, a crystal that repeats. Then we extended it into time. Now, we are beginning to connect that temporal order to the rest of the physical world. And in doing so, we are learning that time is not just a backdrop against which events unfold. Under the right conditions, it can become a dimension of structure, of rhythm, of information. A crystal, not of atoms arranged in space, but of motion arranged in time, quietly oscillating at the edge of what reality allows, waiting to be understood, and perhaps one day harnessed.